When multiplying and dividing rational numbers, we don't actually have to consider the absolute value of any of the factors, dividends, or quotients. We can sort of think of negative in these expressions as the opposite of. That's helpful for me. So if we had, 1/2 times 3, we'd be thinking about what's half of 3. Here we have -1/2 times -3. So I like to remind myself that multiplication is commutative, and we can rewrite this expression as negative times 1/2 times 3. And really, when we're multiplying by a negative, it's just -1 times -1, because positive 1 is the identity in multiplication. And when we multiply by -1, it's just letting us know that we're going to the opposite side of 0. So in that sense, we can think of absolute value. So if we have 0 here on our number line and -1 and +1, okay, and we have 1/2, and we multiply 1/2 by -1, it's really just saying, mirror image, go to the same distance from 0, but on the other side of 0 to get the opposite. So multiplying by -1 is taking the opposite of. And here we can see that we have the opposite of -1, which is +1 times 1/2 times 3. Now we're left with all positive factors. We just have to find half of 3, which is 1 5/10, or 3/2, or 1 1/2. So we see here that the answer here is positive. Two negative factors make a positive product, okay? In this case, we have 3/4 times -100. I'm going to expand this and write 3/4 times -1 times 100, because having that negative up front just means we're taking the opposite of 100. The opposite of 100 is -100. So these are equivalent expressions. So now we can use the commutative property of multiplication and bring this -1 out front and think of what is 3/4 times 100. The law of associativity in multiplication lets us know that we can do the 3/4 times 100 first. And order doesn't matter really with multiplication. So 3/4 of 100 is 75. And we need to take the opposite of 75, so that's -75. So here we have a positive times a negative, and our product is negative. Okay, next situation, now we're looking at division. Division and multiplication respect the same properties and rules. So here we have a -1/3 divided by 2/3. So -1/3 divided by 2/3. I can rewrite -1/3 as -1 times 1/3 divided by 2/3. And instead of dividing by 2/3, I can multiply by the reciprocal. So I have -1 times 1/3 times 3/2. By associativity, I can multiply 1/3 by 3/2 first, and I get 1/2. So I get -1/2, because the opposite of 1/2 is -1/2. And again, we have a negative answer in this division problem. It's our quotient, so our quotient is -1/2. Negative divided by a positive stays negative. There's not another negative symbol to reverse that negative to the opposite side back to positive. So we have -30 divided by -1/2. I can rewrite divide by -1/2 as -30 times -2/1. Okay, if you're not sure about that step, whenever there's a negative symbol, you can associate it with the numerator or the denominator. So we could really write -30 divided by -1/2, and then keep that negative with the 1 if that makes you feel more comfortable. You're wondering, like, why can that negative just stay there? You can associate it with the -1, and then you have -30 times 2/1, and then 2 divided by -1 is -2. Okay, so we have -30 times -2. The same situation would have happened if we associated that negative sign with the 2, and then when we found the reciprocal, the 2 would have the negative sign, and then whenever you divide by a 1, it just kind of is a different notation. It doesn't matter if you just drop that divided by positive 1. Okay, now negative 30 times negative 2, we can bring both the negative 1s out front, have 30 times 2. 30 times 2 is 60, and then the opposite of negative 1 is positive, so our answer is positive 60. Okay, so these are the rules for multiplying and dividing positive and negative rational numbers.